Hello, I'm Svetlana Boriskina, and I'm very happy on behalf of the whole team of students, postdocs, and collaborators who work on this project to talk to you today about antimicrobial and easy care SmartPE fabrics that we're developing. So fabrics is, of course, something everybody uses because everybody needs clothes and bedding and towels. And that's why, not surprisingly, textile industry is one of the biggest in the world. But also, unfortunately, it's one of the largest polluters in the world. And it uses a lot of water and energy to produce fibers and fabrics. And there are a lot of greenhouse gases that are emitted in the process of this production. And then, unfortunately, most textiles and garments are never recycled and just end up in landfills at the end of their life cycle. High-performance specialty textiles occupy a small portion of this large textile market, but they tend to be even more expensive and less environmentally friendly than standard low-cost textiles. And that is because they usually require use of unique materials and even more concerning material blends to achieve that high performance that's needed for a specific function. And that makes materials even less amenable to recycling. So we're trying in our research to address both aspects of this issue. So we are trying to develop material that can provide high performance, but without associated high cost and high environmental footprint, making it not sustainable. So we call our material SmartPE, and PE stands for polyethylene, which is not a unique material. This is a material everybody is familiar with. So it's indeed abundant and low cost. It's just not typically used for textiles. But as you can see in the central picture, it can be cast in the standard fiber, yarn, and fabric form, and it can be woven or knitted. So all the materials shown in the central picture are polyethylene. And it has this nice silky appearance and nice touch, especially depending on the type of weave or knitted pattern. So what kind of interesting performance can we have in our materials? They're actually multifunctional. But one functionality I would like to start with is very important in the current time of COVID, and this is antibacterial performance. So fabrics in general provide fertile ground for growth of bacteria and other microorganisms because they provide this nice environment for them where it's warm and humid next to the human body. And if we look at how much bacteria grows in 24 hours in different fabrics, it's not so much in cotton or other natural materials, relatively speaking, but it's much more in synthetic materials such as polyester, polypropylene, or nylon. So we were pleasantly surprised when our testing this year demonstrated the same rate of bacterial growth on our SmartPE fabric samples as on the reference cotton samples. So this offers interesting solution for a new material that is not blended with anything, and it does not rely on any coating to achieve antibacterial performance. So when we started this work, we did not think about antiviral performance, but we actually know that some of the strategies we are going to try next for providing improving antibacterial performance will also help to fight viruses on the fabrics. And these approaches include spin dyeing our fibers, as shown in this picture, and textiles with metal-based nanoparticles that does not only improve antibacterial and antiviral properties, but also adds stable color and avoids pollution, because the way we add color is very different from the standard coloring techniques in the textile industry that waste a lot of water and color it in different colors, unfortunately. Our fabrics exhibit low environmental footprint, not only by reducing the water use resources, but also by reducing other resources, such as depletion of fossil fuels and abiotic resources, eutrophication of water and land. And if we compare environmental footprint during the fabric production for our material and other conventional synthetic and natural materials, it's actually the smallest footprint in production. One common reservation about polyethylene for use in wearable materials is that normally it's hydrophobic. So if you look on the left, so this is a standard performance of the polyethylene material, which is not very comfortable on the skin. But our specially engineered SmartPE fabrics are actually very hydrophilic, and they allow efficient wicking of perspiration, which helps to provide comfort feeling in hot weather. And how efficient this wicking is, actually it's more efficient than in other fabrics. And the graphic on the left shows comparison of the wicking distance that perspiration can penetrate in 10 minutes in different fabrics. And you can see that this wicking distance is the longest for the SmartPE material. But of course, it's very important that material not only wicks water, but also dry fast. And the drying tests that we performed on our SmartPE fabric and other conventional materials showed that they actually not only wick faster, but they also dry faster. And that helps to promote a comfort feeling and inhibit bacterial growth even further. This combination of properties, together with other properties of good heat conduction and radiation, allow our materials to provide passive cooling. And if we compare the temperature of the skin covered by our material and other materials under the sun in daytime, we can see that we can achieve temperature reduction by a few degrees relative to both synthetic materials and cotton. Finally, interesting property of SmartPE is that it's impossible to stain it, even if you try to do it intentionally, as shown in this picture where we stained different materials with food colorant. But if we then quickly rinse materials with cold tap water without using any detergent, we can see that SmartPE material emerges completely clean, while other materials still remain stained. So this interesting property further promotes a low environmental footprint during the use stage of this material. So all these interesting properties of SmartPE make us believe that it can provide a low-cost, sustainable, high-performance textile option for a variety of specialty markets. And we're looking for students to join our team for the next year, and companies and investors to help us to commercialize this technology. Thank you very much.